One of the unusual things about Nyquist is the support that it has for timing and what I call temporal semantics, which is completely lacking in most programming languages. So we're going to spend this and the next couple of video lectures on programming techniques in Nyquist. We'll be looking at a number of different programming techniques and topics. I'm not going to read all these to you, but just to give you an idea of what's coming. And the first thing I'd like to look at is the idea of recursive sound sequences. As you know, the seek construct delays the evaluation of each behavior until the previous behavior is finished. And this is actually done with lazy evaluation, which is a programming language technique that exists in other languages, not most of them, but some. And in Nyquist, this allows you to express infinite sounds recursively. And so, as a very simple example, think about a drum roll. So what's a drum roll? If we want to define a drum roll recursively, we could say, well, a drum roll is one drum stroke followed by a drum roll. And what's it followed by? Again, one drum stroke and another drum roll. So recursively, we build up an infinite drum roll, one stroke at a time. And we can write code that works almost exactly like that description. We first describe a drum stroke, and this is a very primitive synthesis model here. I'm just taking noise and multiplying it by an exponentially decaying envelope. We'll listen to that in a moment. And now we can define a drum roll recursively as a sequence of a drum stroke followed by a drum roll. Now, if we try to play an infinite sound, that will eventually fill up our disk drive with sound, and it never stops. So we're going to make a new function called limited drum roll, where we multiply the drum roll by simply a constant, which has the value of 1, but a duration of 2. So in fact, this is not really a constant. It's a function that a unit generator that returns a constant value of 1 until it finishes, and then it drops to 0. That's at the stop time. Now, when we do that, the multiplication operator in Nyquist is kind of a smart operator. It knows that when you multiply by 0, the result is 0. And it knows that when a sound reaches its stop time, it goes to 0 and remains at 0 forever. So when you multiply by this constant of duration 2, the multiply operator says, whatever drum roll is doing, I can just stop doing it at that point, and I can terminate because the result will be 0 forever. And so that terminates the recursion. And let's go to Nyquist and take a listen. Here is a drum stroke. Okay, not much to it. And here's our limited drum roll.